Now we will go a little further into the technical flow of how the Humanode Sybil-resistance mechanism works. In this video, we will be focusing on node launch process, biometric enrollment, and authentication flow. To do this, we will go over a few parts of the Humanode network architecture. Number one, Humanode peer, which is the software run by Humanodes. Two, Humanode network, which is our blockchain. Inside of it, we'll focus on two modules, Session Pallet and Bioauth Pallet. Three, a web app that humans use to scan their face. Four, a Robonode, which is a confidential virtual machine making the biometric computations private. Five, FaceTec server, the biometric server. If you want to dig deeper into the network code, we will be leaving links to the open source Github repositories of these modules during the video. Let's begin. Let's say we want to launch a node. The first step would be to run a Humanode peer, which is a software anyone should run to become a Humanode. Cool, now we have an empty node and we need to generate keys in order to register the node in the network. The Humanode peer can naturally work with different keys depending on the operation. These are called session keys and they're used for different goals. We start with the generation of a key BAI private key, which will be your bioauthentication key, and you can even call it your validator key. It is also used to pay for transactions connected to the setting up a validator node, as well as to receive the rewards for running the validator node. For those familiar with our Humanode launcher, the mnemonic you generate and insert is the Bioauth or BAI key. Next step would be key rotation in order to generate 3 new keys. For producing blocks, we have the BAPE keys, and for signing or finalizing blocks, we have grandpa keys. We also have I'm online keys to announce that a node is online and available. Then we need to set these session keys by signing them with our Bioauth BAI key. In this process, we send the session keys to the Humanode network chain state to the session pallet. You are now added to the list of validators, but without an active authentication, meaning without going through biometric processing, you cannot become an active validator. Okay, now we're ready to prove that there is a real unique human behind our node. The first step would be the enrollment of a user. Naturally, the user will need a device for this process, and this device will need the Humanode web app to kick things off. Including into this Humanode web app is the FaceTec SDK. It connects directly to the Humanode peer to the node that you just launched by simply scanning the QR code. This web app scans your face, captures unique traits of it in 3 dimensions, and puts it through liveness detection in the process to make sure the user is an actual human being. Liveness detection has over 60 modules to make sure that the person is a living human, not a deepfake, mask, picture, or injected video stream. Currently, we are utilizing the technology provided by our partner FaceTec to make this as accurate as possible, but remember that we are not tied to one provider, meaning we can add multiple service providers to enhance the process, and we can also choose to add a number of biometric modalities. So the web app generates and encrypts a 3D face scan locally on the user's device, which includes both face map and liveness data. Through RPC, this data is sent to the Humanode peer, which keeps encrypted face scan, liveness data signature, and our BAI Bioauth public key. And with this data, it now asks Robonode client to enroll a human so that you could become a Humanode. Humanode peer also runs Robonode client. Now let's focus on Robonode a little bit. Robonode is based on confidential virtual machine technology. To be specific, we use AMD SEV SNP, the 3rd generation of confidential computing. We built Robonode for 2 purposes. The first one is we want to make sure that biometric data is always in the encrypted domain. And the second one is that we do not want to trust any component of the system. We want to verify everything. And in this case, we want to make sure that the biometric server is not sending faulty data to the chain. In other words, we want to make sure it has a Robonode signature. As I said, Robonode is a part of the chain, and every validator runs a Robonode client. Robonode has its own private and public key, a Robonode server that performs some low-level implementations like commands face scan, use liveness data, pass during request, and uses external database reference ID. And inside the encrypted Robonode, there is a FaceTec server with API and a database. So let us put this together to give you a better understanding of how it works. Imagine you pick up your smartphone device, launch the Humanode web app. After scanning your face and generating face scan, the request is sent for enrollment to the Humanode peer through the RPC, to the Robonode client with the enroll method, which sends this data to the Robonode server, which via API request asks FaceTec server if the liveness data is authentic, meaning that it is a real human being behind the face scan, as well as FaceTec server accesses the database to see if the user is in the database or not. If during enrollment phase Robonode finds out you're not in the database yet, now you can authenticate. The same newly collected data, but with another authenticate method, is now sent again through the flow to execute the necessary action. And the most important step here is where the Robonode client converts the necessary data into what we call an auth ticket. The auth ticket consists of the key BAI public key of the peer that we will use for running the node, and the Robonode signature to prove that the data has been authenticated by the current Robonode. This auth ticket is your permission to become an active validator. Auth ticket is used to send a special authentication transaction to the network. Once the transaction is included into the block, the validator's public key, together with authentication expiration timestamp, is added to the active authentications in the Bioauth pallet of the Humanode network. Bioauth pallet always checks the Robonode signature on the auth ticket against the Robonode public address in the Bioauth pallet. If they match, the auth ticket is accepted. If not, it is rejected, and your validator key will not be added to active authentications. What else is important to know about Bioauth pallet is that for each block created, it uses a special hook that is called onInitialize, which is getting the current timestamp. And based on the current timestamp, the logic can check the Bioauth tickets to see if they are valid or expired. If expired, the node's keys are removed from active authentications. However, if your keys are among active authentications in the Bioauth pallet, it doesn't mean you are an active validator yet. Apart from blocks, which last for 6 seconds in our case, we have 4-hour epochs as well, and now you'll find out why we have them. Alongside the Bioauth pallet, there is a session pallet. Session pallet is responsible for forming the list of validators for upcoming epochs. How does it work? When the session ends, it executes on new session handler, and by that activates, so to say, an intermediary pallet that we developed called Humanode session pallet. Humanode session pallet goes to Bioauth pallet, takes those public keys who have unexpired valid keys, and sends them back to session pallet, which now creates a list of validators. And for the next epoch, these validators are now queued, and they will become active validators when another epoch ends in 4 hours. That's when new validators finally start proposing blocks and finalizing them. I hope that this video gave you a more technical understanding of the flow of the Humanode consensus. We plan to continue to post more videos concerning various Humanode applications. So if you have any requests or comments on how we can make the presentations better, feel free to comment below, and thank you again, and see you next time.